measuring the density of the fibers along the length. Since length are there, so what is the fiber density? That by fibro, not gram. This is fibrograph. Since this is the optical method, there are two important formulas here. Uniformity ratio is 50% of 5%, and the uniformity index is, this is I think not the uniformity index also, right? It mean length upon per half mean. This is very important, and for cotton ranges. So this is if I talk about the fiber fine concepts. So fiber fineness means how fine, and fiber fineness is important. As far as finer the fiber, the more easy it can be dyed, and the reflection of light is also good. The shade of depth on that fibers is also, the uniformity of the yarn would also be good, as we can say that the more finer the fiber, the more uniform is the yarn. Because fine fibers will, because the fiber is supposed to be very fine, and so the yarn that will be made from that fiber will be unique, else it will create a disturbance. So this fineness is measured by micro value, by micronear value. So micronear is basically mass in micrograms of 1 inch of fiber. So if the value ranges between 0 to 3.1, is known as fibers. Between 0 to 3.1 is very fine, and 3.1 is fibers. Rest greater than 6. Last thing is airflow. Fiber fineness is measured in the form of linear density. Linear density is what fineness linear density is? Linear x gram per 9,000 meter linear, and gram per 1,000 meter is x. So this is measured in linear density. The formula is mass is equal to volume in airflow method. Airflow method, what happens actually is airflow method measured by airflow method means how much the air can flow. A typical if we test a fiber fabric, then how this air flow. So it is basically, it is dependent on airflow is inversely proportional 1 upon s. S is the surface specific surface area. Specific surface area means the specific surface area is high. High means the fabric is highly compact fiber. Compact fabric means there is no spacing between them. Then the airflow would be low. The specific surface area is high, then the airflow is low, because there is no space between them for the air to flow. It is not highly porous, it is a very compact structure. So this is how this defined. And what is specific surface area? Specific surface area is basically surface area upon volume. Surface area upon volume. Now, if I talk about this numerical concept, so then surface area is pi dl pi r square l. I talk cylindrical shape, or pi dl, pi d square upon 4, pi r square l for size, r is equal to d is r is equal to d upon r square is equal pi d square by 4, in everything will get cancelled. It is 4 upon d. So specific surface area is equal to 4 upon d. If I put this airflow is inversely proportional to 1 upon s, so is directly proportional to 1 upon, then airflow is directly d upon, means airflow is directly proportional to the diameter. Higher the diameter. Now this vibroscope, last of vibro vibroscope is measured uh, for a determination of mass per unit strength of individual fiber. It measures, it determines by the theory of vibrating string. This vibrate strings are vibrated. On that basis, this mass per unit length is uh, measured, and how this string vibration. So you have read in just school level wave concept. So waves in wave. So in this fibers are treated in a wave like format, and these are swinged so that it forms a wave like structure. And if wave like structure is formed, then frequency is generated. Frequency. So frequency is generated. So on the basis of frequency, if frequency is generated, then there is also tension between the fibers, because fibers are in this manner, too much tension is also generated. Tension is also one of the important parameters which we take here. Mass per unit length. Mass per unit length means it can be text or denier. Mass per unit length. If length is 9,000 meter, then the said as denier, or if the length is 1,000 meter, then text. So both the values can be found by vibroscope. The main important thing is it measures only for individual fiber. Rest other things in the last grade, it can measures in a bunch of fibers also, but it measures individual because individual fibers are created in a wave. The wave is created frequency tension in the individual fibers itself. One formula is important, is equal under root T upon. This is frequency. This is the formula for frequency determination in a vibroscope. If say this lambda is what? Lambda is wavelength. Wavelength is the distance between the waves. So lambda is this difference. And now I will not tell you the detail about this. Detail in the sense how this derivation is. If you want, I can tell you. So it can be 2 LF is equal to upon. Since we have to find mass, so what we have to find for mass? So we have to square both the sides. Is 4. It is 4 L square 2 LF का whole. LF whole square is equal to T upon M is equal to T upon 2L is what? 2 into length is lambda. Lambda is what? Dense wavelength. Lambda is wavelength. Distance between waves, two waves. So lambda is equal to 2L. So in place of 2L, we can write lambda also. It is lambda square F is equal to T square T upon lambda square F is. Now what we have to do is equal to T upon lambda square F. is equal to tension is what? If tension is in the downward direction, it is weight into gravity. Always Wg upon lambda square F square. Since it is mass, and suppose the length we take, if we have to find the denier, then the length we can take is 9 power 5 centimeter or gram denier. We have to find in denier. If we have to find in text, then upon lambda square F square can keep. So if you can write this thing is equal to lambda. Lambda is also L ka whole. So it is inversely proportional. Length of the way mass can be taken out.